Okay, guys, hey, we're back here today with lesson 24.3 relating similar triangles and slope. Quick reminder that slope is rise over run. We'll be talking about that in length here today. Again, it could be a fairly short section. We only have two parts we have to go over, and the key concept is a little bit confusing, so I'm going to just make mention of that. Let's take a look at 24.3, example number one then. And what you're going to see is a quick little video clip, and I don't believe they're going to say much of anything. So what we're looking at here, it says draw the triangle that is an image of the given triangle after a dilation with the center being 0, -2. We have a scale factor of 2. And then we're going to look at the ratio, the rise over run of each triangle. So in this particular situation, that means that right here sits our center of dilation. And so at this point, we're going to multiply the length of this piece right here by 2. And so that means that this becomes this triangle. I'm going to make it was 2, now it's 4. So it takes me out to here. I'm going to do the same thing in this situation. And again, remember, because this is the center of dilation, it's going to, these points are going to go along this line right here and along this line right here, all right, which we've already established this one. And then, so if we take a look then, this is length of what? 3. 1, 2, 3. So that means this should be a length of 6. So we're at 2, 4, 6. You can see it lands right back up on that spot. Obviously, those are similar triangles, which means they're proportionate to each other. Same exact shape, just different sizes. That's how you need to think about it. And so what they want us to do is they want us to take a look at the ratio of the rise of a run. In our original triangle, we had, let me change over to green here, we had a rise on this angle of up, what, 1, 2, 3. So we had a rise of 3 and a run of 2. All right. So that means that the rise over run would have been 3 over 2. The slope would have been 3 over 2. If we take a look at the red triangle, and in the red triangle situation, we have a rise of 3, 4, 5, 6, and a run of 1, 2, 3, 4. And so on the new triangle, we have a rise of a run of 6 over 4, which obviously simplifies down to a rise of a run of 3/2. So how do those compare? The slopes are exactly the same. Okay, the slopes are going to be exactly the same once we simplify that. All right, and obviously if we were to multiply this by 2, which was our scale factor, then we would get that 6 over 4. Okay, take a look at our next example then. Let me erase this entire mess. It says consider the image of the given triangle after dilation with the center being at 0, 0. So in this case, here's going to be your center of dilation, and a scale factor of 1/2. All right. So if I take a look at this particular situation, you can see my original triangle has a length of 4, and it has a rise of 2. All right. So the original has a slope of 2 over 4, which is going to be 1/2. Okay? And if we take a look at my new one, we're going to multiply by a scale factor of 1/2. Now again, one of the ways we learned how we could potentially do this is we could say, hey, I'm going to take 0, 0, and I'm going to multiply each of those by 1/2, leading me to 0, 0 still. So obviously this one stays put. Okay. We could take 4, 0, and if I multiply 4, 0 by 1/2, that gives me half of 4 is 2, and that would be 0 times half is 0. And then on my last point, where am I at? I'm at 4, comma 2 on my black triangle. And if I multiply that by a scale factor of 1/2, then half of 4 is 2, half of 2 is 1. There's my 3 points. So I already have 0, comma 0 plotted. I'll plot 2, comma 0, which is right here. I'm going to plot 2, comma 1, which is right here. So my triangle is this dude right here. All right, and so obviously in that situation, on my newbie triangle, you can see that my rise is 1, and my run is going to be 2. All right, rise of 1, I'm sorry, and a run of 2. And again, you can see that they basically equate to each other. All right, their choices were, you basically have to find the ratio, and so the ratio there should have been letter B, which is correct. Okay, questions on the first part? So that part's, I think, relatively easy to understand. All right, our show today is brought to you by Passmore Gas and Propane. Passmore Gas and Propane. Hopefully you find that as humorous as I did. Thank you. We're going to now move on to part 2. And on part 2, we're taking a look at the following. I'm going to let this young lady take a...
For any 2 distinct points on a non-vertical line in the coordinate plane, you can draw a slope triangle for the line. You can draw slope triangles above or below the line. Here is a slope triangle above the line. It consists of a rise and a run. Here is a slope triangle below the same line. It also consists of a rise and a run.
All right, let's take a look at section 2. So basically what we're going to take a look at here is you have to describe whether you could use the slope triangle to find the slope of a line with the equation y equals 3/4 x plus 5. Now again, let's go back in time here. Recall, this dude right here is your slope, all right? So we know that our slope is 3/4. And recall, that means that our rise over run has to be some form of 3/4. So if I take a look at this first example, okay, I'm at this point right here. Actually, they're below the line. So if I take a look at this point right here and I say, okay, my rise is 1, 2, 3, 4. So it's actually -4. And my run is 1, 2, 3, and that's actually -3. Then my rise over run on this one is going to be -4 over -3, which actually is 4/3. So we would say in that case, no, we don't think that that's going to work as far as finding the slope of that particular situation. Those do not match up. Okay? As I move to my second one, on the second one, I'll do the same idea. Again, I'm below the line, so I'm taking a look. I'm at 1, 2, 3, so I'm going down 3, and I'm going 1, 2, 3, 4. I'm going left 4. So in this situation, my rise is -3, and my run is -4, and so that equates to a slope of 3/4. So we believe, in fact, that that one should work. And you would just do that for the other 2. Now again, after you find the first one, you should be able to decipher, hey, what this slope actually looks like. So I got to believe, just kind of glancing at these, that I'm hoping you look at it and say, hey, it doesn't look like number 3 is going to work, but it does look like number 4 has a chance. Let's verify this. So if I go again below the situation here, below the line, I'm at 1, 2, 3, 4, 5, 6, 7, 8. So I went down 8, and I went 1, 2, 3, 4, 5, 6. Left -6. So the slope there is -8 over -6, which is 4/3. So we do not think that one should not work either. Okay. And how about that last one? Starting right here, we're going to go down 1, 2, 3, 4, 5, 6. negative 6 over negative 8 for my rise over run. And so that should equate to 3/4. We do think that one should work. So this should be no. And we feel as though, oops, this should be no. We feel as though the last one should be a yes. And we're going to go ahead and check those. And we are correct. Okay. All right. Questions there? Again, I didn't think that was too terribly difficult. Hopefully you feel the same way. Now let's take a look at this last comment here. Which slope triangles could you use to find the slope? Y equals 2/3 x minus 4. Once again, recall in our slope-intercept form, right there's the slope. I don't know if you remember what this is going to be, but my y-intercept is what this is. Y-intercept would be -4. Again, that's not going to really help us at this point, but just to be aware of that. So I'm looking for a 2/3 slope. Again, if you want to stay away from the negatives, you could do it this way and say, I'm going to go from this point to this point. I'm going to go up 1, 2, 3, and over 1, 2. So we're saying our slope here is going to be rise of 3, run of 2. So we don't think that one's going to work. Over here, I'm going to go from this point to this point, and I'm going to go 1, 2, 1, 2, 3. And so that one has a rise of 2 and a run of 3. We think that one should work. If we take a look at this cat over here, we're going from this point to this point. We're going to go up 1, 2, 3, 4. We're going to run 1, 2, 3, 4, 5, 6. So the slope there is rise of 4, run of 6, which is equivalent to 2 over 3. We think that our choices here, this is multiple choice. We think both 2 and 3 should work, so we think the answer should be what? Letter C. And letter C it is. Questions there? All right, let me see if I can get you lined up here for this last one, just from an important standpoint. And again, I'm not going to go all the way through this one, but I'm going to take a break here for just a moment.
You can use similar triangles to explain why the slope m is the same between any two distinct points on a non-vertical line in the coordinate plane. If you begin with a line passing through the origin and the point, AB, the ratio of the rise to the run of the triangle is B divided by A. Now dilate the triangle by scale factor K with center of dilation at the origin. The ratio of the rise to the run for the dilation is
Okay, so what we're taking a look here at now is we're taking a look at, in essence, we have a triangle right here, and they're saying that the rise over run is B over A. Even if they don't give you distinct points, it's B over A, all right, which they share with you right here. And what they're saying here is if we dilate this triangle and we dilate it by a factor of K, again, K is an unknown, could be 6, could be 3.5, could be 15, could be a negative number, who knows, okay? But if we dilate it by a number, they're saying that what's going to happen here with that situation is we're going to have a rise over run, and the rise over run is now going to be what? The distance from here to here is going to be K times B, and the distance from here to here is going to be K times A. And so what they're trying to show you is that the slope M is the same between any two distinct points on a non-vertical line in the coordinate plane. And we know this via similar triangles. These are going to be similar triangles. And so you can see what's going to happen here is, in essence, K and A, or K is going to cancel each other out in this situation, again, leaving us with this B to A ratio. And so they're trying to show you that this and this guy are going to be the same exact slope. All right? Okay, thank you very much. Have a great day today.